Hello everyone, I am Vidya Patil, Assistant Professor, Department of Mechanical Engineering in Sharad Institute of Technology, College of Engineering, Yadra. Today in this session we are going to discuss about the different operations performed on lathe machine. So under the subject Fundamental of Mechanical Engineering. So in this session we are going to cover the working principle of lathe machine, types of lathe machine operations, turning, facing, boring, then taper turning, knurling, grooving and thread cutting. So these all operations we are going to see in this session. So first we start from the working principle of lathe machine. So here in this figure we can see the lathe machine figure is here, and second is the working principle of lathe machine diagram. So in first figure there are the different components of the lathe machine here as shown in this figure, that is headstock, carriage, cross side, tool post, compound rest, tailstock, then lead screw, okay, the hand wheel, also this bed, and these are the two legs, okay. So this is the all components of this lathe machine. So as we know, the lathe is one of the most versatile and widely used machine tool all over the world. So it is the commonly known as the mother of all other machine tools. The main function of lathe is to remove metal from a job to give the required shape and size. The job is securely and rigidly held in the chuck or it between the centers on the lathe machine, and then turn it against a single point cutting tool, which will remove the metal from the job in the form of chips. So in the next figure, this is the working principle of lathe machine. So in this figure also the working principle shown, that is again the workpiece is held between the two centers, that is headstock center and tailstock center, and tool is positioned, okay. So tool having the to and fro motion and longitudinal motion. So an engine lathe is the most basic and simplest form of the lathe. So it derives its name from the early lathes which obtained their power from engine. So besides the simple turning operation here described, that is lathe can be used to carry out the operations also such as drilling, reaming, boring, taper turning, knurling, screw thread turning and grinding. So these all operations, that is different operations performed on lathe machine. The workpiece may be supported and driven by different methods also, that is such as a workpiece held between center and tool driven by carriers and catch plates, and also workpiece held on mandrel and which is supported between centers and driven by carriers and catch plates, okay. So sometimes that held and driven by chuck with other end and supported on the tailstock center also, okay. So this is the working principle. Next here these are the different types of lathe machine operations, okay. So generally there are three types of lathe machine operations, that is first type is lathe machine operations done either by holding the workpiece between the center or by chuck, that is first type. That means the lathe machine operations carried out by holding the workpiece between the center or by the chuck, that is turning operation, facing operation, champering operation, knurling operation, thread cutting operation, filing operation, polishing operation, grooving operation, spinning operation, spring winding operation and forming operation. So these 11 operations are performed on lathe machine by holding the workpiece between centers or by a chuck, okay. So again in turning operation also there is a plain or straight turning operations, rough turning operation, shoulder turning operations, taper turning operations and eccentric turning operations, okay. This is first type. Now next second type of operation is lathe machine operations which are performed by holding the work by chuck or face plate or an angle plate, Okay, so to perform operation there is requirement of face plate or an angle plate. Okay, so for that purpose drilling, reaming, boring, counter boring, tapper boring, tapping, undercutting, internal thread cutting and parting off, these 9 operations are performed by using face plate or an angle in with the chuck. Okay, so next type, that is the operation which is performed by using special attachment, which different attachment are used to perform the operations like grinding and milling operation. So these are the 3 types of different operations performed on the lathe machine. Next, now we see one by one operation performed on the lathe machine. We first start from the turning operation. Here these are the 3 types of turning operation, that is simple turning operation, shoulder turning operation and step turning operation. These 3 types of operations diagram I shown here. Okay, so as we know, the turning is the most common type of operation in all lathe machine operations. So turning is the operation of removing the excess material from the workpiece to produce a cylindrical surface to the desired length. So the job held between the center or a chuck and rotating at required speed. The tool moves in a longitudinal direction to give the feed towards the headstock with the proper depth of cut. So the surface finish also of this simple turning operation is very good. Now in a turning operation there are straight turning operation, rough turning operation, shoulder turning operation and eccentric turning operation also, and step turning operation. So we see one by one what happened in this different turning operation. So first, straight turning. What happened in step turning operation? The workpiece is held on the chuck and it is made to rotate about the axis. The workpiece is held on the chuck and it is made to rotate about the axis, and the tool is fed parallel to the lathe axis. So the straight turning produces the cylindrical surface by removing excess metal from the workpiece. Okay, so in straight turning what happened? The cylindrical surface is produced by removing the excess metal from the workpiece by using straight turning process. Next is the rough turning. In rough turning process, the removal of excess material from the workpiece in minimum time by applying high rate feed and heavy depth of cut. So in rough turning, the average depth of cut is 2 mm to 4 mm and that can be given, and feed is given 0.3 to 1.5 mm per revolution of the work. Okay, in rough turning operation, that's why the surface finish is also rough. Next is the shoulder turning. In shoulder turning operation, the when the workpiece has different diameters and is to be turned, and the surface forming steps from one diameter to other, that is called as a shoulder, and the machining this part of the workpiece is called a shoulder turning. So in this figure you can see this is the revolving workpiece and this is the shoulder turning tool. So next is the eccentric turning, when the cylindrical surface two surface axis of rotation with the first axis is offset to other axis, then such a workpiece is machined by using the operation called a eccentric turning. Okay, so there are 3 sets of center holes are also drilled by holding the workpiece. At these 3 centers, the machining operations for each of the surface can be completed. So this is all about the different turning processes. Okay, also in step turning also, in step turning is a turning operation in which the series of steps of different diameters are produced on the workpiece. So the final feature of the workpiece forms the steps. You can see here there is a 2 steps, first step having the diameter d2 and second step having the diameter d1. Okay, so having the different steps. So this is step turning operation. Next is a facing operation. In facing, you can see here, this is in facing operation, there is a facing tool is there So it is an operation of reducing the length of the workpiece. When we have to required to reduce the length, that time we using the facing operation by feeding the perpendicular to the lathe axis, and the operation of reducing a flat surface on the end of the workpiece. So for this operation, regular turning tool or facing tool may used here. So the cutting edge of the tool should set to the same height as the center of the workpiece. So facing also consists of two operations. First is the roughing and second is the finishing. So in roughing facing, the depth of cut is 1.3 mm, and in finishing the depth of cut is 0.2 to 0.1 mm. Okay. Next operation is boring operation. So boring is the operation of enlarging the hole which is already drilled, punched or forged. It cannot produce the hole. Boring is similar to the external turning operation and can be performed in a lathe. So in this operation, the workpiece is revolved in a chuck or a faceplate, and the tools which are fitted to the tool post and is fed into the work. Okay. So in boring there is again counter boring and taper boring. So boring consists having single point cutting tool that enlarges the hole, and it also corrects out the roundness of the hole. So this method is adapted for boring small sized works only, and the speed of this process is very slow. Okay. So in counter boring, the counter boring is the operation of enlarging the end of the hole through a certain distance. It is similar to the shoulder work in external turning. The operation is similar to boring and plain boring tools, or a counter bore may be used here. So the tool is used called a counter bore, and the speed is slightly less than the drilling. Okay, in counter boring. And in taper boring, the principle of turning a tapered hole is similar to the external taper turning operation, and is completely by rotating the work on the chuck or a place plate. So the feeding tool is at an angle to the axis of rotation of the workpiece in taper boring. So boring tool is mounted on the tool post, and by swiveling the compound slide to the desired angle. A short taper hole is machined by hand feeding. Okay. So in taper turning also, as we know the meaning of taper, that is the uniform increase or decrease in the diameter of the workpiece and measured along with its length. So taper turning means to produce a conical shape by gradual reduction in diameter from a cylindrical workpiece, and the amount of taper in workpiece is usually specified on the basis of difference in the diameter of the taper to its length. So it is known as a cone, and it is indicated by the letter K. So the cone, that is K, is also calculated. K is equal to capital D minus small d divided by 1 to produce the taper on the workpiece. Here also in this diagram you can see that is D1 is the larger diameter of taper, D2 is the smaller diameter of taper, L is the length of the taper, and alpha is the half angle of the taper. Next operation is the knurling operation. It is operation, as we know, the knurling is the operation of obtaining the diamond shape on a workpiece for the gripping purpose only. So this is done to provide the better gripping surface when operated by the hands. So it is done using the knurling tool, and the tool consists of set of hardened steel roller, and it is held rigidly on the tool post. So this is, you can see here, this is the knurling tool, and knurling tool having the hardened steel roller. So steel roller is attached here, and knurling tool is mounted in this tool post. Okay. Next operation is the grooving operation. So again, grooving operation is process of reducing the diameter of workpiece over a very narrow surface. So it is done by groove tool. This is the groove tool, and grooving tool is similar to the parting of tool, and it is often done at the end of a thread or adjustment to the shoulder to leave a small margin. Okay. Next is the So here in this session we covered the different operations. Okay, so in next section also we see the different operations performed on milling machine. Okay, thank you.